The robot future will probably not begin with one dramatic moment. It will not be a single humanoid walking into every home overnight.
It will begin quietly, with robots doing boring work in places most people never see: warehouses, factories, hospitals, farms, airports, mines, kitchens, and delivery networks. Then one day, the world will look back and realize the robot race had already started. For years, AI felt like software. It answered questions, wrote text, generated images, summarized documents, and helped people think faster. But software is only part of intelligence. The physical world requires something harder. A robot has to see the room, understand objects, move safely, deal with surprise, and recover when reality refuses to follow the plan.
This is why the timing matters. AI models became better at reasoning, vision, language, and planning. Sensors became cheaper.
Chips became more powerful. Simulation became more useful.
Companies learned how to train systems with huge amounts of data. Put those pieces together and robotics changes category. A robot is no longer only a machine following a script. It can become a machine that interprets a situation.
The International Federation of Robotics reported that 542,000 industrial robots were installed in 2024, more than double the number from 10 years earlier. That matters because the robot future is not starting from zero. It is building on a large industrial base that already welds, lifts, sorts, packages, paints, inspects, and repeats precise movements every day. Humanoid robots get attention for a simple reason: the human world is already built for human bodies. Doors, stairs, tools, shelves, kitchens, hospital rooms, factory lines, and delivery routes were designed around arms, hands, legs, and height.
In theory, a humanoid robot can enter existing spaces without rebuilding everything around it. That is the promise. But the promise is not the same as the product. The hardest robot problems often look embarrassingly ordinary. Folding a shirt. Picking up a cable. Opening a plastic bag. Holding a glass without breaking it. Moving around a child, a pet, or a chair someone left in the wrong place. Humans do these things without thinking because our bodies are full of intelligence. For a robot, every tiny movement is a negotiation with physics. This is why simulation matters so much. If a robot must practice millions of times, the real world is too slow, too costly, and too breakable. Digital worlds let robots fail safely. They can drop objects, crash, retry, and learn patterns before touching expensive equipment or standing near people. The robot race is not only about hardware. It is also a race to build better training worlds. McKinsey describes the future of work as a partnership between people, AI agents, and robots. That framing is important. Agents automate non-physical work: planning, processing, writing, coordinating, analyzing. Robots automate physical work: moving, inspecting, cleaning, assembling, transporting. The real transformation happens when both layers connect. A software agent plans the task. A robot performs part of it. A human handles judgment, exceptions, and responsibility. The mistake is imagining that one technology replaces one job in one clean moment. Work is made of tasks. Some tasks are predictable and physical. Some are social and emotional. Some require judgment under pressure. Some happen in messy environments. Robotics will hit different parts of work at different speeds. The same job can become more automated, more supervised, and more human at the same time. This is where smart cities connect to robotics. A robot does not only need a body. It needs maps, sensors, charging, permissions, routes, data, maintenance, and places where it can safely operate. The more machine-readable a city becomes, the easier it is for robots to work inside it. Delivery routes, hospital corridors, warehouses, elevators, traffic systems, and energy networks all become part of the robot environment. Factories are hard,
But homes are chaos.
Every home is different. Clothes fold differently. Drawers stick. Cables tangle. Floors are uneven. People move objects without warning. A home robot has to deal with uncertainty that no factory engineer designed away. That is why the first useful home robots may not be glamorous.
They may clean, carry, fold, remind, monitor, or help older people stay independent.
The robot race is also a cost race.
A robot that works beautifully but costs too much changes a demo stage, not the world. Batteries, motors, sensors, hands, compute, maintenance, insurance, and safety systems all matter.
If costs fall and reliability rises, adoption accelerates. If the economics do not work, even impressive robots remain expensive experiments. There is another side people ignore. A robot is not only a machine that moves.
It is a sensor platform with cameras, microphones, maps, logs, and sometimes biometric clues about the people around it.
In a factory, that can improve safety.
In a hospital, it can improve coordination. In a home, it can become deeply intimate.
The question is not only what robots can do. It is what they are allowed to remember. Imagine 2030. A warehouse near your city runs with robotic fleets overnight. A hospital robot moves supplies so nurses walk less.
Inspection drones check power lines after storms.
Farm machines monitor crops before disease spreads. A restaurant uses robots for repetitive prep while people handle service. None of it feels like a science fiction movie.
It feels like operations getting quieter, faster, and more automated.
The winners will not be the companies that buy the flashiest robots. The winners will be the ones that redesign work around them.
That means better processes, safer permissions, human training, maintenance plans, data governance, and clear rules for when a human must step in.
A robot is not a magic employee.
It is part of a system, and weak systems make expensive robots look stupid. The real robot race is not only about who builds the strongest machine.
It is about trust. Can it work safely near people? Can it explain what happened? Can it be stopped? Can it protect data? Can it fail without causing harm?
The more robots enter daily life, the more society will demand proof that these systems are not only impressive, but dependable.
The robot age will not look like one robot replacing every human.
It will look like thousands of small physical tasks becoming machine-assisted.
It will look like cities adapting, jobs shifting, factories changing, and homes slowly gaining machines that can sense and act. That is the future signal. The robot race has already started, and by 2030, the world may feel different in ways people barely notice until they are everywhere. Subscribe to Future Signal if you want the future before it feels obvious.